Hello everyone, in this video I'm going to discuss the example for limits and continuity. Evaluate the situation given. So notice that we have the square root of x squared. So let's define the situation. If we have the square root x squared, so meaning that we have the modulus of x. So based on the definition we have x greater or equals to 0, negative x is less than 0. Illustrate in the real number line, we have the negative x for the left hand side and we have the x on the right hand side. So if we substitute the negative infinity, and we will have the infinity over negative infinity, where we have indeterminate form. So the strategy will be dividing the numerator and the denominator with the highest power of x for the denominator. So in here we notice that we have 6x plus 5, so we have to factor the x. Limit when x approaching negative infinity, square root, we have the x squared bracket 4 minus 3 over x squared. Over, we have the x bracket 6 plus with 5 over x. Rewrite the situation. So we have the square root of x squared bracket, we have the square root 4 minus 3 over x squared. Over, we have the x bracket 6 plus with the 5 over x. Kindly refers to the situation in here. We have the square root of x squared. Actually, it's the same for the modulus of x. Based on the definition, we have x approaching negative infinity means that x less than 0, or we have the negative x. So limit when x approaching negative infinity, here we have the negative x. Multiply with the square root 4 minus 3 over x squared. Over, we have the x 6 plus with 5 over x. Kindly simplify because we have the common terms. Then limit when x approaching negative infinity, negative square root 4 minus 3 over x squared over 6 plus with 5 over x. So if we substitute the negative infinity, then here we will have 0, then here we will have 0. So we have negative square root of 4 over the 6. Limit when x approaching negative infinity for the situation square root 4x squared minus 3 over 6x plus with 5. Then we will have the situation negative 2 over 6, where we have 1 over 3. Next, given we have the function fx. So in here, illustrate the situation in a real number line, where we have the 2 and also the 5. X less than equals to 2, where we have 2x. Continue, we have mx plus with the n. Then we have 3 minus x. So that is the situation. Determine the value of the constant m and n such that f is continuous. So when they mention continuous, means that limit exists. So limit when x approaching 2 from the left is the same with the limit when x approaching 2 from the right. So for the function, we have the 2x, mx plus with the n. If we substitute, we have 4, which is equals to 2m plus with the n. That is the first equation. Second part, limit when x approaching 5 from the left will be the same limit when x approaching 5 from the right, because we have the mention that f is continuous, limit exists. So kindly substitute 5m plus with the n equals to, we have the situation negative 2, second equation. Continue. First equation minus the second equation, so we have the 4 minus the negative 2 and we have 6. 2m minus the 5, we have the negative 3m. n minus with the n, we have 0, so m is equals to the negative 2. Substitute m equals to negative 2 into the first equation. So 4 is equals to negative 4 plus with the n. So n is equals to 8. Next, so we have the y, which is equals to 2 over the square root. We may factor the situation x plus with the 2, x plus with the 2. So number 1, find the domain. So notice that we have the all real number for the 2. Then we have x plus with the 2, x plus with the 2 greater than 0. So this is the simplest form, positive. Next, x greater than negative 2, x greater than negative 2. So we have the negative 2. Then we have the negative negative, so it becomes positive, positive. So the domain for this case, where we have negative infinity until the negative 2. Union the negative 2 until infinity. So that is the domain. Next is to find the limit. So focus on the negative 2. Vertical asymptote, limit when x approaching negative 2 from the left. Limit when x approaching negative 2 from the right. Can you substitute the function? So refers to the real number line, we have the negative 2. Negative 2.0001. Negative 1.9999. So if we substitute this one, then we will have a positive. Continue, we will have a negative. Then here we have a negative. So at the end, we will have the positive infinity. Continue, if we substitute negative 1.999, we will have a positive. So in here, we will have a positive. Then here we have a positive. So finally, positive infinity when x approaching negative 2 from the right. Then from here, we can say that the vertical asymptote is x equals to negative 2. Next, continue. For the horizontal asymptote, limit when x approaching negative infinity. For the function, we have the 2 over square root x squared plus theta 4x plus theta 4. So if we substitute the situation, negative infinity, so for this part, we will have 2 over infinity. So for this case, limit when x approaching negative infinity for the function 2 over square root of x squared plus theta 4x plus theta 4, and we will have the value of y approaching 0. Continue. Limit when x approaching positive infinity for the function 2 over the square root x squared plus theta 4x plus theta 4. If we substitute, for sure we will have 2 over infinity. So limit when x approaching positive infinity for the function 2 over the square root of x squared plus theta 4x plus theta 4. And the value of y will be approaching 0. Horizontal asymptote is y is equals to 0.
If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.